Hey, math friends. So our learning target today is I can review Unit 2 test review. So everything from Unit 2 in your review packet will be discussed here. So the first learning target is using the slope formula to calculate slope of the line. So using slope formula. So if we're just using the formula, then we're not going to rise over run. We need to identify two key data points. So I will choose those two. This data point is right 1, up 1, 2, 3, 4. Again, we're asked to use the slope formula for the learning target here. Down here we have right 2, up 1. So if we were to set those into a table, or you can use your y2 minus y1, I'm going to do the same thing. I'm just going to organize in a table. We're left with the data points of 1, 4 and 2, 1. We're still going to find the change in the y's and the change in the x's. So we're going to subtract here, and we're going to subtract there. So 4 minus 1 gives us 3, and 1 minus 2 gives us -1. So if we simplify that, we end up with a slope of -3. That's using the formula only, not using rise over run. Pause the video at any time. Over here then, my data points. Now be careful about the scale here. We're scaling by 2's. So this data point would be 6. And if you don't see a scale on the y-axis, you always just assume that it's going by 1. So this would be 6, 3. And likewise, this would be -6 because -2, -4, -6. And we're going down 1 unit. So -6, -1. Again, because we do not see a scale on the y-axis up and down. So I'm going to make sure that I'm following the same learning target. Use the slope formula. Even though the graphs are there, that's what the target says. So we're going to plug those data points 6, 3 and -6, -1 into the graph here, or into the table here. We're still going to find the change in y's divided by the change in x's. So the change in y's would be 3 minus -1, be careful on that, is +4. 6 minus -6, 6 minus -6, be careful on that, is 12. If we were to reduce this, because you know we have to reduce, if we were to reduce that, we'd end up with 1/3. Divide the top by 4, the bottom by 4, results in the slope of 1/3. Of course, you could run it and double check that you agree that the rise is 1/3. The rise and the run is 1/3. That's using slope formula. Go ahead, pause video at any time if you're stuck. Learning target, the next learning target says also use the slope formula to calculate the slope of the line that goes through the 2 points. Same thing. Then it says plot your points to check your answer. So kind of twofold here. First use the formula and then plot your points to confirm. So when we do that, we get -2, 1, +4, -1. The operation is to find the change in the y's and the change in the x's. So where I'm getting that is that y2 minus y1 over x2 minus x1. I'm just organizing it in a table, but still doing y2 minus y1 divided by x2 minus x1. As we subtract the right side, we have 1 minus -1 is +2. Watch your sign there. And the right side then, -2 minus -4 is -6. This reduces to, so this reduces to negative, and 2, 6 reduces to 1/3. We can divide the top by 2 and the bottom by 2. So that's using the slope formula, part 1. Then it asks us to plot the points on the graph and confirm that we have the correct slope. So if we plot our points, we'd go back to the 2 data points that were given from the very beginning. This data point and that data point. If we were to plot those then, left 2, up 1, right 4, down 1. So left 2, up 1, right 1, 2, 3, 4, down 1. And we're finding the slope of that line. So if I use my line tool, which you don't of course have access to, Give it your best shot. You got this. You got this. And if we were to rise run it then, and this is another option called the rectangle method, or I just call it that. The rise here is 2. Okay. The run here is 1, 2, 3, 4, 5, 6, which is 2, 6. Although I should have written that it's negative because it is a decreasing line, gas coming out of tank. Not sure I put a positive there. And is it true that this negative 2, 6 reduces to that negative 1/3? Check. So the check here on the graph, if we rise run it, do we get the same answer? Yes. Boom. All right. Next learning target. Use the table method to solve the following problems. So we're identifying proportionate situations using tables. So first problem says Kendall bought 2 pairs of pants. Stop. Pants. Table. How many pairs? 2. Boom. Get it in the table. For $30. 2 pairs of pants for $30. Some of you might be able to see right out of the gate there that the slope or the unit rate will be $15 per pair, per one. How much will it cost? How much will it cost? There's our unknown for 5 pairs. So make sure we put the 5 under the P. Taking cross products and solving. Actually, before we do that, I'm trying to get this to extend, but I don't know if it will work. Before we do that, we have to analyze. In this lesson, we learned about whether something's proportionate. We're going to check to see, is it true that if you buy 0 pairs of pants, that it will cost you $0? Is it true 0 pairs of pants cost $0? Yes, that's true. And if that's true, if we say yes, that's true, we know it's proportionate. This is what we learned in the lesson when we watched the video. Therefore, we can take cross products. So we get 2x is equal to 150. Divide both sides by 2. Copy, paste, copy, paste. So we end up that x is equal to $75. So now, if we write that at a data point, we will say that 5 pairs is $75. So if we go back to the original problem of what is the question here, 5 pairs is how many dollars? 5 pairs is $75. Boom. Cool. Next problem number 5. Alec runs 12 laps in the same time as Surrey runs 16 laps. So you're trying to process, are they starting together at 0, 0? That will be super important for us. They begin running at the same time. Boom. There's our answer to that. How far has Surrey run when Alec completes 9 laps? So let's get our table set up. First of all, we have Alec and we have Surrey. Alec runs 12 laps in the same time that Surrey runs 16. And then we're saying, how far has Surrey run when Alec completes lap 9? Great. But the question is this proportionate? Does it go through 0, 0? Did they start at the same time? It says right here, they begin running at the same time. So yes, it is proportionate, which allows you to use cross products. So go ahead and use cross products and then come back and solve. All right, so let's see how you did. When we multiply here, we get 12 multiplied by x, and we get 16 multiplied by 9. So we multiply 16 by 9, we get 144. Divide both sides by 12, so we find out that x is 12. 12 what? 12 laps. So we would say for our solution then, 9, 12 is the data point we're looking for. How did I get that? I got it from the original table that says, if Alec is on lap 9, what lap is Siri on? We would say, well, if Alec is on lap 9, Siri is on lap 12. So Alec and Siri. All right, pause video at any time and go back. All right, here we go. Next problem. 4 pencils cost 50 cents. How much will 18 pencils cost? So 4 pencils cost 50 cents. How much will 18 pencils cost? So our job then in this scenario is to check for proportional relationships. Is it true that if I buy 0 pencils that it will cost me $0? Is that true? I'll let you catch up. Go ahead, pause video at any time if it's going too fast. That's the beauty of a video, right? You can pause it at any time. You can rewind. All right, so we take cross products and solve. When we do that, because we have identified it as proportionate, 0 pencils cost $0. Now we can take cross products and solve. I got ahead of myself there, maybe. So 4x is equal to 1/2 of 18 would be 9. Divide both sides by 4, copy, paste, copy, paste. So we find out that the x value is equal to, whoops, oh boy. It must be that the x value, sorry about this, that the x value is equal to $2.25. So $2.25 for what? $2.25 for 18 pencils. So if we write that as a coordinate, back up from the beginning here, 18 pencils cost how much is the question we're answering. So we're going to say that 18 pencils cost $2.25. That would be our solution there. That would be our solution to the problem. We recognize that we were able to use cross products because it is definitely proportionate. All right, so if we were to graph that then, make a graph, we can see that our variables have already been established for us, that the y is equal to cost and the x is equal to the number of pencils. Number of pencils. The number of. All right. It looks like my x ranges from 0 to 18. I'm not going to have enough space to go by 1, so I'm going to go by 2s on the graph. Now, if you don't have graph paper at home, you just need to sketch a quick graph of it. That's 12, 14, 16, and 18. You're going to have to roll with the numbers down there. Just sketch a quick graph. It doesn't have to be perfect. If you do have graph paper, great. If you have the packet, well, actually, this was in the review, so you don't have that anyway. Each of these are going to represent 50 cents. I got to get up to 9, though. Might not make it. Actually, each of these are going to represent 25 cents. I think I can get it. 25, 50, 75, $2. Nope. Each of these are going to represent 50 cents. So I'm going to go up by 50 cents, $1, $1.50, $2, $2.50, $3. So I'm just going to roll with that for my y-axis. There isn't a perfect solution to what do you scale by. You just need to make sure you get enough data points in the set. All right, first data point is 4 pencils, 50 cents. We've already established 0, 0 because we said it's proportionate. So I need one more data point. 18 pencils, we've established, we just found the answer would be $2.25. Well, this is $2.25 would be somewhere right there. So we're going to go ahead and connect the dots, la, 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 la here. And there's our graph for that. Representing our answer then to the question of 18 pencils cost us $2.25. So 18 pencils, $2.25. That's supposed to be a 5. Boom, got it. So let's go answer some questions down here. Find the slope of the line. We have some choices here. You can use rise over run, which is not super friendly in the graph. Yeah, I think I will. I think I'll use it. Rise over run in the graph then would be this box right here. So the rise would be 50 cents. And the run would be 4 pencils. So your job is to figure out how much does it cost for 1 pencil. And we're talking about money here. So we really should be rounding to the nearest hundredth for money. So when I type that in, I end up getting this for my answer. It's a money problem, so we're going to go ahead and round that say that means it costs about 13 cents for 1 pencil. 13 cents for 1 pencil would be the slope of that line. You can either get it from your y2 minus y1, or I pulled it right from the graph. So the equation then would be y equals, the cost is equal to 13 cents per pencil. That would be our equation. The y-intercept there is at 0 plus 0 because it's proportionate, and we know that there isn't a cost for 0 pencils. So use the equation from part D to calculate your answer. We should be getting the same answer that we got from the table and the graph. That's part of this learning target, is prove that your answer for table and graph is the same. So 13 cents per pencil, we're multiplying that by 18 pencils, and our answer should be very, very close to $2.25 when we're done. And I end up getting $2.34, which is close. Just something to prove to you that if you would have went back before we rounded and used this value that came out in our calculator, type that in with what we get before we round, you will see that we did indeed get that perfection before we round. So just FYI on that. Once you round, you kind of take the perfection out of the problem. All right, moving on. Let's see. Next problem. Miss Shirlene walks at the speed of 2 miles in 40 minutes. So Miss Shirlene is 2 miles. Careful on that. 2 miles in 40, or 2 miles. Ooh. Ooh, that's tricky. 2 miles in 40 minutes. Mr. Boulanger walks at a speed of 5 miles in 50 minutes. Boom. They begin walking at the same time, which proves that it's proportionate. So we can just use 0, 0. Now, typically I like 3 data points. So I think I'm going to throw another one in here just to get me some more data points. Oh, it says at least 4 data points. We're going to only use 3, though. I'm only going to use 3, which is fine, especially in distance learning mode. Divide by 2 for the 40. Divide by 2 for the 2. That gives me another data point. Of course, you could do that again. You could divide by 2, but then we're going to have some decimals and things. I'm going to divide by 5 and 5 here, which divide by 5 gives me 10. Divide by 5 gives me 1. Okay. It says 4 data points. I'm only going to do 3 as stated. We see that the labels are already there for us, that Y means miles and X means minutes. Okay. So now we got to get both of these riders. Are they riders? What are they? They're walkers. Both of these walkers graphed. So Miss Shirlene has the biggest X she has is 40. Mr. Boulanger, the biggest X he has is 50. So we have to fit 50 on this line over here. So I'm going to go by 10s. 10, 20, 30, 40, and a 50. We're talking minutes. Now, when we look at the Y's, the miles, the smallest or the greatest Y that Miss Shirlene has is 2. The greatest Y that Mr. Boulanger has is 5. 1, 2, 3, 4, 5, 6, 7, 8. I'm just going to go by ones. I think that's the best I have to offer here. Boom. Got it. So now we're going to start to graph. I wish I could change some colors here. Let's get some better colors. Hey. Yes, yes, yes. How about like a pink and an orange or something like that? How about an orange? So Miss Shirlene at 40 minutes, so over 40 up to the origin, and then over 20 up 1. So Miss Shirlene's graph looks like this. Boom. Mr. Boulanger's graph, over 50 up 5, 0, 0, because they started at the same time, and over 10 up 1. So you can see that Boulanger is steeper, growing faster than Miss Shirlene. So there's our graphs. Boom. Okay, that's that target. Find the slope for Miss Shirlene. Find the slope for Mr. Boulanger. So this time I'm going to use the data in the table to get my slope. So if I look at the data in the table, we would subtract our y's. So I'm going to subtract our y's, which gives me 2. I subtract my x's, which gives me 40. That reduces to, so 2/40 reduces to 1/20. And if we convert that to a decimal, which sometimes we like decimals, sometimes we don't, is 0.05. These are all equivalent to each other. The lowest terms is always the best answer. Lowest terms is a fraction, and then anything in the decimal method. All right, so let's take a look at Mr. Boulanger. Mr. Boulanger, we subtract here, we get 5. We subtract here, we get 50. So Mr. Boulanger's slope, if we reduce 5/50, divide top and bottom by 10, gives us 1/10. 1/10. Now, if I put a placeholder in there and compare, you can see that definitely Mr. Boulanger has a greater slope, growing at a rate of, let's think of it as 10 cents compared to 5 cents. So it should make sense that Mr. Boulanger's line is steeper. Write an equation for Ms. Shirlene. So we're going to go ahead and write that equation for Ms. Shirlene. So we get we get y equals 0.05x. And Mr. Boulanger, we get y equals 0.10x. And that, of course, that 0 placeholder does not have to be there. So that's the 2 equations. I'm going to let you pause and catch up if you need to. I'll pause the video as well. All right, we're back in the game here. So the final question is, how far has Miss Shirlene walked when Mr. Boulanger completes mile 8? So we have to think of variables. Mile 8, miles. Which variable represents miles? Look in your table, look in your table. Which variable represents miles? Y. So when y equals 8, what's the time for Mr. Boulanger? So let's start with him. And then we'll come back to Shirlene after. So Mr. Boulanger's equation is y equals 0.10x. So when Mr. Boulanger gets to mile 8, how long does it take? So we're going to divide both sides by 0.10, copy, paste, copy, paste. So we do that, think. What happens when you take 8, divide by 10 cents, essentially? Means that it was 80, what's the units? Go back and look at the units. Was it minutes for X? Uh-huh. So here's our situation. Mr. Boulanger at 80 minutes went 8 miles. Now that's actually not the question here, but we needed that data to answer the question, how far has Ms. Shirlene walked when Mr. Boulanger has gone 80 minutes. Okay, now if that's confusing, rewind it. That is a kind of a tricky statement. We know Ms. Shirlene is walking at this speed. And we want to know how far miles, that's the unknown, has she walked when Mr. Boulanger has gone that far. So that's 0.05 times 80 minutes. How far has she gone in 80 minutes? And you can see that she has gone 4 miles. He went 8 miles. She went 4 miles. So she went in 80 minutes. She goes 4 miles. So this is Shirlene down here. Boulanger's up above. So a lot of stuff going on in that problem. So keep going. We're already at 24 minutes, but this is the review. All right, you and your friend spent $50 tickets on Valley Fair to rent a locker for all your stuff that costs $5 per hour. I don't know if I can change all of this stuff right now. I'm going to pause the video and see if I can move. All right, so $50 on tickets, that's your entry fee. So you should be thinking about, ooh, that sounds like a Y-Intercept at the beginning. That's the cost at the beginning. and it's $5 per hour, you should be thinking like, oh, that sounds like a slope. How much would it cost for 6 hours? Use your table to find your answer. So 0 hours. So if you're not going to rent a locker, like you don't need one, you have somebody to hold your stuff. If you don't rent a locker, you just have to pay the $50 to get in. If you do rent a locker for 1 hour, you're going to need the $50 to get in plus $5 for the cost of the locker. And we need to know what happens for 6 hours. So I think I'm just going to keep going down the table here. So 2 hours would be another $5 to rent the locker. So the increase is $5, which by the way will be our slope. That's our rate of change per hour. Double check my work here. Let's see, I started at 50, 55, 60, 65, 70, 75, 80. So what I'm thinking is that, and I'll have to prove that in the graph and an equation, but if I rent a locker for 6 hours, I will need a total of $80 to go to Valley Fair because the cost of the tickets is embedded in there. The Y is the cost. That's stated, that's given to us. X is the number of hours that we do what? That we rent the locker. Our X's range from 0 to 6. So when I graph that on my X-axis, it would be 0 through 6. Now, again, I know that this is at my pace because I don't have anybody with me to have a conversation about it. So I'm going to just keep going at my pace. Just click pause. If you don't have graph paper, write in a separate piece of paper. Just sketch one out. It doesn't have to be perfect. Just give it your best go. All right, now when we talk costs, the least amount is $50. So if we start at 0, we don't need anything from 0 to 50. So I'm just going to start at 50. But when I do that, I need to break my graph, which we talked about in the videos, that we just need to break the graph if we're going to make a jump. And then I'm going to roll by my slope. So 55, 60, 65, 70, 75, 80. All right, we're trying to prove that 6 hours is $80 when we graph it out. Gives us a nice straight line. Graphing those data points then. 0, 50. 0 hours of locker rental, $50 to get in. 1, 55. 1 hour of locker rental and the $50 to get in. 2, 60. 3, 65. 4, 70. 5, 75. And 6, 80. There's my line. That's the linear graph. It is true that $80 would be the cost for 6 hours of locker rental. That's supposed to say 80. So $80 for 6 hours of locker rental. That does confirm it that it's the same answer. And then also in the graph, we are also in the equation, we're going to need to do that. So first things first, what is the slope of the line? All right, so you have some options here. You can run it. You can use your table. And some of you can pull it right from the original problem. That the rise here would be $5. And the run here would be 1 hour, which is confirmed in the table as well. The Y-intercept is the place where the graph starts, which is $50. We said that it would cost $50 to get in to Valley Fair. Even if you don't want to rent a locker, you still have to pay $50 to get in. So write an equation. Y equals $5 per hour of locker rental plus $50 for tickets to get in. This would be my cost, and this would be the hours of locker rental, X. Use the equation from part D to calculate your answer. How much would it cost for 6 hours of fun at Valley Fair? So Y equals $5, 6 hours of locker rental, and $50 to get in. We're just confirming that it still would be $80. So $30 for locker fee, $50 for your tickets. Y, the cost would be $80. Confirming, final, that 6 hours, boom, is what? $80. We knew that. Table, graph, equation. Awesome. We're almost at 30 minutes. Last problem of the day. is a whopper of a problem. And then, of course, the final page is just the answers that are available to you always on the packet. But I'm just going through that video right now. To become a member of an ice skating rink, you have to pay a $10 membership fee. That sounds like a B to me. Okay. The cost of admission to the rink is $2 for members. That sounds like a slope. And $4 for non-members. So kind of a different scenario. Make a table for 8 visits. All right, here we go. If you are a member, you have to pay the membership fee. So if you're a member and you go 0 times, you still have to pay the fee to become a member. And that happens sometimes with people in like even like a gym membership, right? They sign up to go, they pay the membership fee, and they never go. However, if you're not a member and you don't go, so you're not a member, you don't go, you don't pay anything, 0, 0. Now, once you've decided whether you're going to be a member or not, you do have to pay per time at the rink. The cost is a little different though. It's $2 for a member and it's $4 for a non-member. So I'm going to go ahead and throw those into my slope, wherever the slope is. Members cost, sorry about that. So members cost $2 per time. And we said it's a $10 beginning amount. So Y equals $2 per time that you go if you're a member and a $10 membership fee. All right. Now, non-members, where? Non-members pay $4. So let's go down and check that out. So non-members pay $4 per time and a $0 membership fee. So Y equals just $4 per time. All right. So now, what is the cost for 8 visits in the 2 scenarios? Okay. So each time a member goes, remember they're paying $2. Each time a non-member goes, they're paying $4. So just keep that in mind as we work. So $2 every time you go. Work it all the way to 8. So each time we go is $2. So I'm coming up with that 8 visits would be $26. Okay. So how does that compare for the non-members? Well, they don't have to pay anything if they're not going to be a member. But every time they go, they have to pay $4. So we're going to work the table. This is sometimes frustrating, you guys. We're going to work the table for 10 visits. So that's $4 every time they decide they want to go skate. They're not a member, so they didn't have to pay the membership fee, but they do have to pay the $4 instead. So we would say $4 every time. We're going to work the table all the way to 8. All right. So now if we were to graph this out here, we would know that Y is the cost and X is the number of visits to the ice skating facility. And then we would want to graph that out. Now, because I'm using this stylus that's a little tricky to use, I'm only going to put a couple data points. I'm going to put this one, I'll put this one, and I'll put that one maybe. So first figure out our X and Y axis. Our number of times we go ranges from 0 to 8. I think I can easily get that 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Oh, plenty of room. So what I'm going to do is I'm going to skip a line and then put 1. So skip a line 1, skip a line 2, skip a line 3, and so on. Stretch out this graph a little bit. Since I have the space, I might as well use it. Make sure you're writing on the lines, not the spaces. So 8 visits. And then the cost ranges from $0 for non-members all the way to $32. And if we take a look at our y-axis, we get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. I'm going to go by 2s, which should work out pretty well for me. So 2, 4, 6, this might not. work out so well for me after all. All right. So I'm going to start at 2 there. I'm going to try this again. 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, bear with me, 24, 26, pause the video if you need to, 28, 30, and 32. Now I recognize those numbers are not necessarily super easy to read. I need you to just roll with me on that. All right. So 0, 10, 0 up 10 is our y-intercept. 4, 18, and 8, 20. This is a 26, by the way. 8, 26. Okay, so this is the cost, and I only graphed those just because the pen I'm using is not very good. It's the cost for members. That's what it costs. They start at $10, and that's the rate that they grow. Non-members, they start at the origin, and then I'm going to pick 2 other data points. Maybe, so we'll take this one. Maybe, I guess I'll take the same ones. All right, cool. So 4, 16, 4 up 16. All right, that's a pretty tight race there. And then over 8 up 32. And that is for the non-members. Now you can see that initially it's better to be a non-member. It doesn't cost as much. But eventually you get to this point where it would make more sense to be a member. And that change kind of happens here. Right here. There's kind of a change that's happening of there's a tie, and then after that it's definitely cheaper to just get that membership. So that's what we're going to talk about down here. And how many visits to the rink is the total cost for members the same as the total cost for non-members? So we see it in the table. We're supposed to see it in the graph, but as we've talked about, the pen I'm using is really tricky, but it's supposed to be this data point rather, that at 5 visits, we have a point of intersection. At 5 visits, going to cost $20 either way. So at 5 visits, it really doesn't matter, membership or not. Okay, so I marked it in the table. It says how many visits? 5 visits. How much does it cost? $20. It says label the point in the graph. I did that. And then finally, you're trying to decide if you should get a membership or not. Suppose you predict that you will go to the rink 20 times this year. Should you get a membership? Well, here's what I would say. If you're going to go from 0 to 4 times, you should not get a membership based on what our table and our graph says. Our table says 0 to 4 doesn't matter. 0 doesn't matter. But the 5th time, it's a tie. Same thing is true about the lines over here. Actually, I misspoke. 0 to 4 non-members actually pay less. Same thing with your lines over here. You can see the blue line is lower than the green line. The cost is lower. But on that 5th time, things start to change. So at 5 visits doesn't matter. Just doesn't matter. But 5+ visits, you definitely want to get a membership. So go back to the question that's being asked here, which is, if you're going to go 20 times a year, what do you want to do? You better get the membership. It's significantly cheaper for especially 20 times a year. So that wraps up Unit 2 on tables, graphs, equations, slope, all those big events. Lots and lots of graphing. If you don't have graph paper, you might want to get some, but not required. Definitely not required. Have a glorious night.